Hello, this is Cristina Rodriguez from Green Delta. First of all, I want to give some hints about how to use GoToWebinar. So as some of you have mentioned, all of you are muted right now. This is because large audience is expected, so more than 70 attendees. So it would be a bit chaotic if everybody could talk at the same time. That is why I would appreciate if you could raise your hand if you have any question, and then I will unmute yourself and you could ask your question, or you can also use the question box, which is in the bottom of the panel, and write there your question. I will then read it. I will allocate some time for questions at the end of each block of content, and then also at the end of the webinar for the remaining questions, because just for not stopping too much between the explanations, I will only allow a couple of questions for what has been just explained. You can see also that in the handout section, there is the manual included in the openLCA website for regionalization. So in case you have not checked it already, you can download it from here. It contains more or less all the explanations that I will present today. So if you have any additional question or unsolved doubt after the meeting, of course, you can go through the manual. I will also be posting the recording of the webinar after the second webinar, so at the end of May. And then, yeah, you can also go again through it, or if any of your colleagues couldn't attend today, they can check it there in the YouTube channel of openLCA. You should be seeing by now my screen in a second window in your computer. If you don't see it, please let me know, so we wait or we check what's the issue. Okay, so if there is no problem, let's start with the content of the webinar. I will be presenting today the new functionalities included in openLCA for the regionalized lifecycle impact assessment. So first, I will mention just a short introduction of why is needed regionalization, why we have to apply this, and why we went through for the approach I will be presenting. And then I will focus on the features added, so how to add geographic information system data to the inventory location, how to implement Regionalized LCIA methods in openLCA 1.5, and then how to perform the calculations while we have added the two previous data in the two previous points, and how to analyze the results obtained. Hopefully by the end of the webinar, we will have still some time for questions, for discussion, and for commenting what's going to be the next steps, or what could be the next steps regarding regionalization in openLCA. So first of all, we have to take into account that Regionalized LCIA is model sophistication, is adding a new level of complexity into our models. That is why commonly nowadays, the practitioners tend to ignore these regional differences when performing the impact assessment phase. So we are using by default global average parameters, causation factors, which might be okay for some impact categories like global warming, but they are not really representing the reality for other impact categories, such as freshwater consumption, land use, acidification, etc. For example, imagine the withdrawal of 1 liter of fresh water in the Netherlands and in the south of Spain, both for watering crops. Do you think that the impact will be the same regarding freshwater consumption in both cases? Well, if we are using these global average causation factors, then we are assuming, yes, that the impact is the same. But we know that that's not really the case. That's why it's very important to consider regional variations of the, for example, water stress index in its region. Luckily, there are more and more regionalized LCA methods available nowadays. So I listed here some examples, I know, but of course, there are many others there in the internet. The good things about these ones is that they not only provide the impact factors as Excel files, but also using EIA's files. So for example, save files, Google layers, etc., which is very, very useful then for implementing them in openLCA. Of course, they might not provide regionalized Cartesian factors for all the impact categories, as I mentioned before, but for example, in the LC impact, you will have for acidification, for land use, for water depletion, to the same as in the ecological scarcity or in the enhanced eco-indicator 99 plus with the Pfister methods for water depletion and also for land use. So of course, we need regionalized Cartesian factors, but we need also regionalized inventory data sets. And we are becoming more and more, they are becoming more and more available national databases, for example, the Brazilian database, the Malaysian database. There are several initiatives to continue providing region-specific inventory databases, but also generic databases like Ecoinventor Gavi provide region-specific processes, for example, for the electricity mix, so per country, but also in the Ecoinventory too, for example, we can find in subnational level, like in China, with multiple different electricity mixes there. In Nexus, we can see here in this map the distribution of datasets in the world. So you can filter and have a look if you want in nexus.openlca.org, which datasets are available in the different locations for the databases included in our repository. It is interesting, for example, databases such as Regionalize or USDA, which provide agricultural processes for France and US respectively, which maybe it's a sector that is, of course, highly affected by regional variations. So there are already even implemented for openLCA regionalized inventory databases. How to then combine both the inventory and the LCA methods in the software? Well, there it comes the trick. In the past, we used to have elementary flows specified for the different locations. So one flow per location, like in this example with the LC inventories, where we see different water emission flows for different countries like Austria, Switzerland, Belgium, etc. And then these flows were used in the process dataset. Of course, if we are only modeling water, it is not such a big issue. But if we start working with all the elementary flows in the database and all the different impact categories for not only the regions included in the processes, but also the regions that we want to use for defining the characterization factors, because maybe we don't want to define them per country, but we will rather define them per water set in the case of water stress index, or per ecoregion in the case of land use, etc. So it's becoming more and more complicated if we follow this approach, huge amount of data, which is very difficult then to handle with the software and in a user-friendly way. That is why we decided to go for another approach. The approach is to integrate geographic information system data into the software, because this allows us to really be able to handle this huge amount of geographic data. And also, instead of defining an elementary flow per location, what we are doing is that the location of the elementary flow in the inventory result would be the location of the process consuming or emitting it, so of its contributor. As I'm going to explain later, each of the different changes needed in the software for including geographic information system data, we can see here that on the one hand, what we allow now is to provide KML data per location included in the database and in the product system. So the KML is keyhole markup language, is an XML notation for expressing geographic annotation and visualization with internet-based 2- and 3-dimensional browsers. So we will see that we have maps integrated into openLCA, which can be then used for defining the geographic data for the different locations. So that's for the inventory side. For the LCA method side, what we allow now is to include shapefile parameters. And shapefile is also a geographic data file. It's a vector file for including polygon lines, point, which allows then to define also different attributes for the different geographies included in the shapefile. And these attributes can be used as parameters then in the Regionalized LCIA method in openLCA. So basically, we have two sources of geographic information, the KML data in the inventory and the shapefiles in the method. When performing the regionalized LCIA calculation, what we do is combine these two informations and calculate the regionalized impact factor per substance, impact category, and location. Then combining the corresponding regionalized impact factor with the inventory results, we can obtain the regionalized LCIA result. So don't worry if right now you think this is quite complicated, because I'm going to go through each of these new functionalities, and hopefully by the end of the webinar you will have really clear concept of what we have done and how it works. Let's start now checking the locations in openLCA. So if you may remember, in openLCA 1.4, what we had was under the file preferences locations, a list, just a table with the different locations included in the database. The only geographic information that we had for them was the average latitude and longitude that were included in the table. This was coming from the IRCD format, for example, that included this kind of information. Of course, this is not enough when we want to perform a fully regionalized LCIA, so we needed to extend the amount of geographic information included per location. But also another limitation was that the processes could only use existing locations, so it was not possible to define locations within the process. So how it looks like now in openLCA 1.5? Well, what we did was moving from that table in the preferences to a new element into the database. So now the locations, if we look them into openLCA, are within the background data as other background data flow properties, unit groups, etc. We have now a folder called locations. This is then working as any other element in openLCA. So if you want to create a new location, you can just right-click and select new location. A window will open where you can just type in the name and the code. The code is very important because it would be the information shown next to the process and the product. So to identify then in the database what's really the geography without needing to open the process or the flow in its editor. So remember always to set the code. And we see now here a new editor where we can set a description too if we want. And then we have the latitude and longitude information, which we have in the past too. We can enter them. But we also see here a KML editor, so the map where we can define our KML information. If we don't set any KML information and we save the location, what will happen is that by default, a point with the average latitude and longitude will be created. This is not included in the beta 1 that is available in the website, but it will be included in the final release of 1.5, hopefully next week. So don't worry if you don't see it, if you test it later, but that you know that will be included. So we have the point created. Why we do this? Well, it's a way of allowing the user without needing to create themselves the KML information that a regionalized LCA calculation will be able to be performed. Why? Because if you don't have KML data within at least one location in your product system, then the regionalized LCA calculation will not be possible to be conducted. So now all the new locations with an average longitude and latitude data will have at least 1 point for the KML data. Of course, we can change this. We can just click on Clear Data, and then use the different options we have, the polygon, line, and point that it's on the top of the map, as we see it here. You can select one of these for creating then the KML information, the geographic information for your location. You can combine multi-geometries, but of the same type only. So if you try to add now a point, you will get an error message saying that only multi-geometries of the same type are supported. Then the last one that you draw will be gone, and you will just be kept with the equal type geographies. You can use the zoom in option. There is also a hand option to move around the map if you want. And this would be the way of creating them using the map. But there is also a text editor, which contains the same information as in the map. We see here the coordinates that I just created. We can modify them here. So if now I write another coordinate and come back to the map, we see that the polygon was changed consequently. So you can use indistinctly one or the other. The information would be displayed in both with the same data. Of course, creating a very complicated and complex geometry with the KML editor can be time-consuming and really a huge effort. That is why we allow also to import directly KML information and EcoSpol2 geographies files into openLCA. For that, you can just right-click on the locations folder and select import KML geographies or import EcoSpol2 geographies. Or you can also go to File, Import, and then in the other folder, you have here again EcoSpol2 geographies, KML geographies. So you will just select the geography file and import it. There are lots of sources for this kind of information for different regions, countries, etc. on the internet. So, for example, you can take the EcoInvent geography website, where you have for all the locations included in EcoInvent, which I would say it's for the generic databases, most of the locations you will find, with KML information, save files, etc. So in a lot of formats, all the geography information. But there are also other sources. I just wrote here the US Census Bureau website. And here you will find also KML data for the different states, counties, etc. in the US. I am sure that for most of the countries, you will have some statistics or website from the government with this kind of information, so you could use it. Of course, you can create your own locations too, either with the KML editor or also in an outside tool and import them as KML or as EcoSpol2. The linkage will be done considering the code. As I said before, it's very important, then the code used for defining our location. So take that into account. Okay, so this would be the location editor, but we can also in openLCA 1.5 create locations using the process editor. And for that, what we can do is just go into the geography section in openLCA in the process, and we see here, for example, that we have for Germany, we can click on the KML data, and the KML editor that we see is a bit different from the one in the location editor will be opened. We cannot change here an existing location, but what we can do is click on Open in Editor, and then the editor for that specific location will be open in openLCA, and we can change here the location as we want. We can, though, create a new location. So, for example, we can clear the data and set, for example, I want just a point for Hanover, and save this as a new location. So now this location will be creating new. It will be open in the editor, and in the process it would be selected as the location. If we save the process, then this would be the location used for the process and for the calculation. So this would be the information regarding how to add geographic information to the locations in openLCA 1.5. So once we have created this, we can move on to the LCA method. Okay, so as I mentioned before, the approach for the LCA methods is parametricize them using shapefile parameters. So what we do is taking the attributes containing a shapefile and use them as parameters in the LCA method. For you to understand, if you are not familiar with geographic information system data, I'm showing now just the QuantumGIS. It's an open source software for GIS, and here we have a layer for permanent crops land use from LC impact. So if we open the attribute table, what we see is that each row represents a geometry, a feature within the map, and then we have in the columns the different attributes. So in this case, the factor representing the impact of that specific region for occupation permanent crops. What we will do in openLCA is use this column as a parameter, so this attribute as a parameter in the LCA method. So there are some specifications for the shapefile, of course. The coordinate reference system has to be the World Geodetic System 84. Of course, if we are using different coordinate systems, then in openLCA, when making the intersections between the KML data and the data in the shapefiles, then would be a mess. So we need to use the same coordinate system. Then the attributes that can be used as parameters should be numerical attributes. The text attributes then are not used as parameters. Also, there must be a single layer in each shapefile, and the names of the attributes in the shapefile, which will be the ones used as parameters, needs to be unique. Why? Because if in openLCA, if then you are using this to define the formulas and you have two parameters with the same name, that's not really working. You have to define unique names for the parameters and therefore for the attributes in the shapefiles. So if you are using multiple shapefiles within a method, you have to take this into account. Another limitation is that you cannot have geometries that overlap themselves. For example, you cannot have Europe and Germany in the same shapefile. If you want to define characterization factors in the supranational level, for example, in Europe level, and in the country level, you have to provide them in two different shapefiles. Okay, and you cannot perform the calculation together at the same time with different spatial resolutions. Okay, then the shapefiles, after being imported into openLCA, they are stored in the database. So you can search them by exporting as Zolga or as JSON format. And this is very useful then because you can easily exchange the data with our colleagues or partners. There are different options regarding the content of the shapefile parameter. So what should be defined in that attribute, in that parameter? On the one hand, we can decide to use the parameter just directly as the regionalized impact factor. So we will just use this parameter in the impact factors tab of openLCA to define the formula of a specific substance. As we see here, for example, occupation annual crop has the factor annual crop, which is coming from a shapefile with the corresponding content. We can see, for example, this is from LC impact. So if we go, to the LC impact example I have created, we see here different save files for the different types of occupation flows with the corresponding characterization factor. We can use them in the method by right-clicking on the name and saying Add to Method Parameters. By clicking there, the parameter will be automatically added into the input parameters in the Parameters tab of the LCA method. The average value will be automatically calculated considering the maximum and minimum values of the save file, but we can change this to the global average, for example, that we want to use, because this value will be the one applied when there is no regionalized LCA calculation selected, so for the quick results and the analysis, but also in those cases where we have not defined the location for the process, or that specific location doesn't have KML data included on it. So that's why it's important to set well the average value to use for the parameter. The uncertainty is also automatically calculated when adding the parameter from the save file, but we can also modify it by clicking Edit and selecting the distribution that we want to use and the corresponding parameters. However, one limitation that we have right now is that the uncertainty will be a fixed value, a fixed uncertainty. It cannot be modified by also the locations, the regions, because we cannot use parameters in the uncertainty. In the uncertainty definition. So you have to take this into account. We see in the description from which save file it's coming, the value, as well as in the external source. We can modify the external source. So for example, as I mentioned before, imagine you want to provide the impact factors in different spatial resolutions. So you want to provide them per ecoregion, but also per country. You can import the two save files, use the same, in this case, use the same name for the parameter. And then here you will be able to select the different save files, including a parameter with the same name for the calculation. And then the values will be recalculated taking into account the values in the save file we have selected. This is interesting when we want to sometimes perform the calculation with one spatial resolution, another time with others, and we can use just the same method we had created. We don't need to create several methods for that. So once we have here the parameters, we can go to the impact factors tab and here write down just the parameter name. In this case, because we are making a one-to-one, so the parameter is the impact factor. We select as normal, we select just the flow we want to characterize and define then the factor. We can, however, follow another approach, which would be to, instead of saying the save file parameter is directly the characterization factor, the impact factor, what we do is include it in the save file parameters regional characteristics, so site-dependent characteristics, which are used for the calculation, the final calculation of the impact factors. That means we are going to write mathematical functions, formulas in the impact factors tab, combining both region-dependent characteristics and region-independent, so multiple types of parameters. And then we are going to obtain with this the final characterization factor. Why is this approach interesting? Well, because we can reduce a lot the amount of data imported into openLCA and used into openLCA if we can somehow extract only the really region-dependent characteristics from the calculation in the LCA model. This, of course, is something that only the method developers can do, or someone really studying what's behind the calculations. But it might be interesting for you, the ones who want to implement your own methods into openLCA. Let's see an example so that you understand exactly what I mean. This is the land use model from the VAN implemented in the ecological scarcity 2013 method. What we do here is analyze how is this ecofactor calculated. So we see that we have weighting factor, a normalization factor, and then we have a regional characterization factor. So what we want to know is how is this regional characterization factor calculated? If we analyze how it's calculated, we see that what it's doing is multiplying the biodiversity damage potential from the VAN of biome 5 by the ratio of species density to biome 5 from Kier et al. 2005. And then divided it by the reference flows of the settlement area. So basically, from all these formulas, the only parameter that depends on the region is the ratio of its biome to biome 5 from Kier et al. So we can define in openLCA different site-independent parameters, and then only one shapefile parameter used for all the different land use substances that we will be characterizing the impact category. So let's see this, for example, in openLCA, how it would look like. We see here, we have the shapefile imported. So we just click import. Of course, I forgot to mention that. We just click import, and then the shapefile, we select the directory with the shapefile, and it could be imported and created. The parameters, the numeric attributes will be created here as parameters. And as said before, we just can right-click, add to the method parameters. It would be in the parameters. And here we define also the other parameters needed for the calculation. And then in the impact factors, we just write the different formulas for the different substances. So we are using the same factors, but with different substances and the impact category land use. The same might happen with water scarcities, for example, or other kind of regional characteristics. Of course, I can understand that this approach might not be feasible for all the impact categories because it might be difficult to extract those region-dependent parameters or models from the calculation. That's why you can also use the first approach I mentioned. In the shapefile tab, we have also their functionalities. So for example, when you right-click on the parameter name, you can also show it in a map. So a new window will be displayed. And you can check here, clicking on the info button on the right top, and then on one specific region, we see here then the information contained in that shapefile for that specific point. So as I said before, only the numerical attributes can be used as parameters, but the rest of the data is also imported, and we can see it here. So for example, we can see here that this corresponds to the biome 1, the tropical and subtropical moist broadleaf forest. And we see that the ratio of the biome is 1.96, which will be the one then used in the calculation if our process location is placed in that region. There is another interesting functionality, which is the update button here on the right side of the screen. This option allows us, if, for example, we have updated of our shapefile and have new values, we don't need to import it again, add the parameter again into the parameters tabs, etc. So we can just click on update and then select the new file, and it would be updated the values. Of course, we need that the parameter name is the same, and I would recommend that there is no new or less parameters in the shapefile, so it's the same shapefile but with new values. So that will work then okay. If you want to delete a shapefile, you can just then click on the remove select button. So that would be the part of how to add regionalized impact assessment methods into openLCA. I see that there are some questions, so let me check. Where is the LC impact tab that you have open stored in the database? Okay, that corresponds to a regionalized method, but it's just a normal impact assessment method. In the impact assessment method folder, you can clear just right-click, select new LCA method, and yeah, it will be created. And here, then you have the different tabs. So in the save files, you can just import and create new impact categories if you want, etc. Then why openLCA uses save files to define parameters? Can't parameters be defined in KML files? I thought it was possible. Well, it could be possible. This is the approach we follow using save files. I'm sure that my developer colleagues, Michael Schrock and Sebastian Greve, analyzed the different options and went for save files because it was probably the more practical, or because in the Java library that was installed in openLCA to handle with EIS information, which was GeoTools, maybe it was the one that worked better. So I can, yeah, if you are interested on the specific reasons, I can, of course, come back to you with a more detailed answer from my colleagues. Okay, then let's move on to how to calculate now result. So once we have defined both the KML data in the inventory and the regionalized impact assessment methods, we can just in the calculation properties window, when we have created a product system, select the option regionalized LCIA in the calculation and the corresponding impact assessment method. As I mentioned before, for making this kind of calculation, it is necessary that we have shapefile parameters in the method and that at least one location in the product system contains KML data. Okay? What the calculation does is calculating the intersections between the different geometries in the KML data and the geometries in the shapefiles and calculate weighted average values for the parameters, for each regional parameter. And from these values, then the final impact factor is calculated. Of course, this intersection calculation takes quite some time if you have very complex locations in your product system and multiple locations, as well as several shapefiles with multiple parameters, etc. So I would recommend that you use the Evaluate for Existing Locations button included in the shapefile tab of the LCA method, and just leave it maybe in the night or while you are doing other kind of things. So when you are not going to need openLCA. The good thing is that once you have run this button, this option, then the calculation time for the Reanalyze LCIA would be as fast as any other calculation in openLCA, which is really great. So it would be a one-time effort, and then you will be done. Once we have performed the calculation, we will get the different results. And we have new tabs in the results for analyzing the regionalized impact assessment results. So for example, we have a results map. Here you can filter by flow in the inventory or by impact category. And you will see displayed in the map the contribution per impact in a qualitative way, so with colors. For example, in this case, we see that for this product system, which is jasmine rice national average at farm gate in Thailand, taken from the AgriValize database using as background data equipment 2, we see that the major contributor is in the Middle East. And then we have also in brown Thailand. So this is for freshwater consumption. If we are a bit surprised about why we have this high contribution here, we can use the other tabs included in the analysis. For example, the impact analysis tab might be very useful because this tab provides information of contribution of the different processes per impact category, displaying which flows in that process contribute to the corresponding overall result, containing the inventory result and also the impact factor that was applied for that specific flow and process. So that flow for that location. This allows us to identify, for example, if the high contribution is coming due to a high inventory result or it's coming due to a very high impact factor, which is the case, for example, here with the water unspecified natural origin from crude oil at production onshore from the Middle East, because we see that the inventory result is quite low, but the impact factor is really, really high. Of course, the water scarcity in that region it's really important. So that is why it's affecting them so much in the impact result. Then we have the second contributor, as expected, the water consumption for the jasmine rice production in Thailand, with an impact factor of 16, which is, of course, much lower, even if the inventory result is much higher. We have also the possibility of analyze the contributions per location in the Locations tab. And here we can also filter again by flow and also by impact category. We can change the cutoff if we want, or exclude zero entries. That means that showing results that have zero contribution or not. Here, for example, we see for the land use regionalized per ecoregion, I'm using here the ecological scarcity 2013 method, by the way. Yeah, we see the major contribution Thailand as expected, and then within Thailand, then the different sub-contributors there. So it's like the contribution tree, but then per location. So we see the different contributions here to the overall location impact. I made in this method, I included impact categories regionalized and also non-regionalized, so we can see easily just with one calculation what is the difference between applying regionalized LCIA or not. So here, for example, for land use, we see that the impact has increased in 300 ecopoints for the land use per ecoregion, and for freshwater, we see also 5 more. Yeah, the cofactor is 5 times 5 values more than, less than when performing just with global values the calculation. So we see that the results may vary quite a lot, so it's important to take into account the regionalization, and if we decide that it's something needed for our study, of course, for the impact categories that we are going to analyze and the product system that we are going to analyze, then it is interesting also to perform this kind of sensitivity analysis to see how it varies using one or the other values for the result. Okay, so that would be the calculation and the analysis of results. So what's going to happen now with openLCA? What are we going to do? Well, the first thing is, of course, provide Reanalyze LCIA methods for openLCA within the openLCA website or Nexus. And for that, we had already been in contact with the developers of Impact WordPlus. Some of them are in this call today, and LC Impact. So we really hope that in the next month, we will be able to provide these methodologies with fully regionalized in openLCA. And, well, also others like the ones I used for my examples, like the ecological scarcity 2013, or maybe the also enhanced eco indicator 99, etc. But also if you have any method you want to implement in openLCA, please let us know. You will receive a survey after the meeting, and there is a question regarding this. So if you are interested, just fill it in and we will get in contact with you. Then other ideas for future projects, because of course we do these implementations through projects, and Right now, there is no project related specifically to Regionalized LCIA, but we have some ideas for the future. So, for example, included the Regionalized LCIA calculation in the project level, because right now it's only possible in the product system level. Also, as I mentioned, the part of the uncertainty and the regionalization is still not fully implemented. So also being able to include regionalized LCIA in the Monte Carlo simulation and also being able to define uncertainty of the regionalized impact factors would be very interesting to do. So of course, support is welcome and ideas too. Just let us know if you have some, and we will try to work together. I want to thank, however, the previous projects and supporters we have to being able to get into this point in openLCA 1.5 with the regionalization. And those are the US Department of Agriculture and the National Agricultural Library with a project carried out between 2013 and 2014. This was where the integration of the geographic information system data in openLCA started. But then also SCS Global Services supported us and we had a project with them between 2014 and 2015 to enhance this existing regionalized LCA calculation done in the previous project, and also to integrate a plugin for their LEO SCS 002 standard. This plugin allows to set virtual locations for the product system. That means that imagine you are in a screening phase and you want to check how would be affected the result if you are performing the calculation for a specific process in another location. But you don't want to change, of course, the location of the process because the process has been modeled for that specific original location. So you can use this plugin just to perform temporary calculations for different locations, so virtual locations. If you are interested, and I don't think we will have time today, but there is in the manual explanation about the plugin. And yeah, if not, just contact me or SCS Global Services for further details. And it's also an interesting feature included in openLCA 1.5, but not by default. It is in the plugin manager, so you will need to go to File, Plugin Manager, and install the corresponding plugin. So thank you very much. This is from my side everything I wanted to tell you today. I don't know if there is any other question or comment you want to do right now. Yeah, there's one person asking, I would like to know which impact method is recommended for water. There are several methods. It would depend also in your specific project, but as I mentioned, there are several. You can take in Pfister method for freshwater consumption, for example, included in the enhanced indicator 99. You have also freshwater consumption in the ecological scarcity 2013, in LC impact. I'm sure in impact world 2, etc. So you can take different methodologies. I cannot really just recommend one, but those are the ones I know. You can maybe take a bit on them, and what exactly are you assessing in your product system. Okay. Yeah, Google Maps, you mean, yeah, can create KML files, geographies? Yes, of course, you can use GIS software and convert it to the KML format needed to import. If you want an example of KML file that can be imported into openLCA, you can check the geographies eco-invent file, which we tested and it was okay. Yeah, and modify it and import it into openLCA, of course. Are there regionalized methods regarding Brazil? I think that these methods I mentioned contain regionalized impact factors for the whole world, so you can use them, but maybe in the call there are specific Brazilian LCA method developers who can also recommend to you any specific Brazilian method, but the ones impact wall and LC impact, etc., they have also Cartesian factors for Brazil, because they at the end they characterize them per water set, per ecoregion, etc., and these are included in Brazil too. Okay, you need to study to understand all variables. Yeah, if you have any question, just contact me. I will be happy to explain further any doubt you may have. I know that it can be also if you are not used to work a lot with openLCA or also with regionalization, that it might be a lot of information for one day. But yeah, hang on then and keep trying. And if you have any question, just let me know. Yes, some people are recommending Google Pro. As I said, I'm using also normally the QuantumGIS, but because it's a free open source software, but you can use any other software too, of course. Yeah, the IRCD format, as I mentioned, only contains average latitude and longitude information for the locations. So we are going a step further. Coinvent went a step further with the EcoSpol 2, including the KML information in the EcoSpol 2 format too, and that's why we are using the EcoSpol 2 format for geographies, or the KML format, which is then more generic after, of course. But the IRCD format does not include this kind of specific geographic information. And if there is no other question, then I will set for finalize the webinar. As I said, they would be published, the recording, after the second webinar, if you want to check it again. And you will receive a follow-up email in an hour, more or less. I think it's program, which contains a survey. If you have time and if you want, you can fill it. If not, of course, you can also send any email if you have feedback or questions. So thank you very much, and hope to see you again in another webinar.